this lecture, what we will do is that um, job sequence deadline and next problem optimal merge pattern. We introduced this problem in previous lecture, and in this we will see the solution for this optimal merge pattern. And then Huffman coding we will see, and we will see spanning trees also. Right. So what is optimal merge pattern is that is, let's say, given two files A and B, all right, having N and M records, yes, respectively. To merge them using two-way merging, it requires N plus M record movements, all right. It requires N plus M movements of records, right? So, yeah, because if it is, this will come here, this come here, yeah, this is the fake. Given N files, it is rigid to merge them using two-way merging. It is required to merge them such that the total number of record movements is minimum. Yes. So how we will do this? That wow. So let's say there's a file here which give this we want pattern which is generating minimum number of record movements. All right. We want that pattern. So this is two-way, right? Two-way merging, right? So it's a four, I think. No, yeah, right. So a greedy strategy. So if let's say if is a file F1 with 10 records and F2 with 15, F3 with 5 records, alright? So for merge this 5 and 10 requires 15 movements and 15 and 15 requires 30 movements. Total number of movements is 45. The number of record movements is equal to weighted internal path length, right? So weighted internal path length, weighted and external path length is equal to distance from root to Fi and frequency size of file I. Can you see? So what are we doing here is that the number of record movements is equal to weighted external path length. Alright, external path length means path length is equal to that di, the distance from root to Fi. This is 1 2. Alright, so how we will do this that and frequency also. What the frequency means? 1 into 15 and 2 into 5. Right, this is how we are doing the frequency thing. Di, that distance from root to Fi is a distance 1. This is 1, this is 2, right? This is 1 here for them. For this is also 2 distance. Frequency size of 5, right? So if we do this, 2 into 10, 1 into 15, 25, and this also. So for this, the 4 into 2 and 4 into 5 also here, and this is 1, 2, 3, 4. 2 into what? 1 into 18, 1 into 29. No, 29 is not the thing. 2 into 12, right? So, right, 100. Optimal to a binary merge tree. Right, number of record moments is this 100. Right. So, what would be the greedy method? Would be that tree node record. Tree node record equal to tree node asterisk child, tree node asterisk left child and right child, integer weight. Alright, so it's a record also. Yes, alright, ठीक है. The algorithm tree of n list is a global list of n single. So a list is a global list of n single node, and binary trees as directly described above. That way, list is a global list of n single nodes, right? Binary tree is described as node binary trees, single node binary trees as described above. This is the tree node, right? So again, for I 1 to n minus 1, do what thing? That pointer 1 is equal to get a new tree node, PL child, list, merge two trees with PR child, smallest length, right? Merge two trees with smallest length, weight, PT weight is equal to PT weight going to be child weight plus PT or child weight going to be weight. Right. It's a novel also. Insert list.pt. Return list. T left is the merge. So in this case, 5. First we 2 and 4. We're going to 6. And it becomes 6 now. 5 and 6 here. It becomes 11. And at 11 and 8 then. Right. So how we do the right? So to minimize this length, so we want to what we want. We want to minimize the length with to merge length would be the same, but the width more frequency. Frequency means size of file. Alright. Size of file is more, then for that file length should be less. Should be less. So if we are going to this, in this case, the length should be less because we know the formula frequency fi into weight I over the size of I, the length of distance from the root. So this is how we do. And time complexity for n files that implement uh, implement of list, that linear linked list or heap. Insert is n and insert is list is n, insert is 1. Order of n square. Heap is insert, delete, log n, and log n. Time complexity is so delete and log n. So space complexity input n. Space complexity is order of n. So space complexity is this. So space complexity input n, space complexity order of n. Right. N files. So now time complexity is and log. Least, find least means what? Order of one, I think. Many linear order of one least. Delete is log n. Insert is also log n. For n this n type. Right. So, so let's start Hoffman coding what an application of optimum merge pattern. Alright. It's also a application of this data encoding plus data compression technique. Alright. So represent an element with some code. Encoding is represent some element with some code, right? 100 characters, 7-bit character, right? Equals to power 7 would be 128. We can represent the 7-bit character, 7 bits per character. So log to n bits. For a characters per element, straightforward 2-bit normal encoding 00, 01, 10, 11, right? So 100 characters are there, different, distinct, right? Then 2 to the power 7, 7 bits per character, right? Data compression is never possible with uniform encoding, right? Compression possible with non-uniform encoding, right? Yeah. So what we are saying that no, the all 7 bits are not provided to all characters, all right, to identify, all right. So what we are saying that codes are assigned based on frequency. So what we are saying that codes are assigned based on frequency, yes. Non-uniform encoding, yes. So Huffman coding, what we are saying that sigma of A, B, C, D, N, the probability of these coming is only this probability. With the highest probability, we will assign on the lowest bit to identify, alright? So this is A. Is highest probability, there's only two bits, 1, 0, alright? For B is less than 4. C and for 0, 1 bit only. And 4 is the highest, alright? So 0 only 1 bit. From that grade, 2 bit for D, 3 bit, and 4 bit for E, alright? And 5 bit for this, alright? Right? So average number of bits equal to DIQI to into this 1.914 कन्वर्टर चला लो ना तुमसे कोई बैग होगा ना मुंह में चला पंगा मैं वैसे पसीना आ रहा है जुकाम बुखार से so guys what we are doing here is applying Huffman coding for these codes. How we will do this? 1 bit for this 1 0. How do we? I think even so. Yeah, left side. Yeah. So this is smallest one. Left side is 0 and right side is 1. And we will evaluate from left to right. All right. So for what? No, from top to bottom or bottom to top. I think top to bottom. I think yeah. So for A, 1 0 is there. Yeah, 1 0 is there. For B, I think where is B? There is 1 1 0 0. This is how do we do the this is we can decide and uniform encoding will 30 bits and for the 1 2 3 4 5 1.95 and 5 and 2 how many characters 1 2 3 4 5 17 bits only. So this is the advantage of encoding. Encoding plus what is encoding? Encoding plus data compression technique. Right. So ooh, right. So this is a good save. Right. Huffman coding is this. Automotive encoding binary encoding 3. This is the root also. Right. So let's the characters are there. Characters A to H have set of frequency based on the first Fibonacci numbers as follows: A1, 1, right. When coding code used to A and B is left, then C. When code is used to represent what is the sequence of character corresponding to the code. Yeah, this is the sequence here. Right. This is also. Is there any right side 1 1 1 1 left side 0 P 0 1 Q is this R is T is if a message of 100 characters over X is encoded using open coding in the expected length of the encoded message of the bits is 5 per character. 225 is this. Right. So was homework there. 23. So we will discuss this later, but we are into 'At least so this is a probability, alright? Probability for this a length. How 225 should be the answer, no? Yeah, 225 is the answer. Yes. Consider this is graph. Name Cauchy spanning tree is the graph based problem. So V is equal to n vertices, E is equal to edges, undirected and weighted. Unweighted. There are two types of graph. Set of vertices, set of evident vertices matrix could be present, and list based and array based, array sequence. Right. So we will thank you guys. We will meet you in the next video.